Hey guys, today we are going to review factoring special cases. We're just going to be looking at how you factor what we call a difference of squares. But before we jump in, I first want to look at what happens when we multiply two binomials like this. If you look at the binomials, we see that both of their first terms are the same. They're both 3x's and the second terms are both 5's. But the difference is one is a subtraction and one is a plus. So if we multiply these and we FOIL, 9 times 3x gives me 9x squared. 3x times 5 is 15x. But then negative 5 times 3x is a negative 15x. And negative 5 times 5 is negative 25. So what happened here is the plus 15x and the minus 15x cancel with each other. And we're left with just 9x squared minus 25. So there is a pattern that happens whenever you have two binomials like this, and we call it a difference of squares. And that is because if you look at the first term, 9 is a perfect square, so is x squared, and then 25 is also a perfect square, so we are subtracting two perfect squares. So we can memorize a shortcut rather than trying to factor in a more complicated method. So here's kind of your formula. If I have a perfect square minus a perfect square, we can factor it to be the square root a plus b, coming from the square root of b squared, times a minus b. So the first terms will match, the second terms will match, one will be a plus, one will be a subtraction. And again, you can notice or pick up that these are a difference of squares because in math, difference means subtraction, and then you will have two perfect squares that are being subtracted. So kind of a visual here, if I have x squared minus 4, I know x squared is a perfect square, but so is 4. I can write 4 as 2 squared. So I have a perfect square minus a perfect square. So to factor it, I'm going to have x, not x squared, but x, and not 4, but the square root of 4, which is 2. So I'm going to have x plus 2 and an x minus a 2, so one of each sign. So let's practice doing a few more. Let me zoom in a little bit. So on this one, I see I have x squared minus 16. X squared is a perfect square, 16 is a perfect square. So in order to do my formula, I know I'm going to have two parentheses. One will be a plus, one will be a minus. I just need to know what's going to go in the front and what's going to go in the back of each one. So to get that, if x squared is what we are starting with, you want to take the square root to get back to its root. Well, a square root and a square cancel, and I just get x. That's going to go in the first part. For 16, if I take the square root of 16, that is equal to 4. That's going to go in the second part, and you're literally done. That's your answer. And so you will get really quick at these. That's the whole point, is to be able to use it as a shortcut to go a lot faster. It comes in handy, especially on things like the ACT where you were looking for speed. Let's try another one. See, I have a perfect square. 4 is a perfect square, so is 25. So again, to do my factored form, I'm going to have one be a plus, one be a minus. I just need to get the front parts and the back parts. We get those by taking the square root of each part. So the square root of 4x squared, well, the square root of 4 is 2, and the square root of x squared is just x. So 2x is going to go in the front. And then 25, if I take the square root of that, is 5. That's going to go in the back. So my factored form is 2x plus 5, 2x minus 5, and I'm done. Let's do another one. Okay, so on this one, we have 100, which is a perfect square. So 100x squared minus 1. Remember, 1 is also a perfect square because 1 times 1 is 1. So if I want to write the factored form, 1's a plus, 1's a minus. We just need to take the square root of both parts. So the square root of 100x squared will be 10x. That's going to go in the front. And then the square root of 1 is just 1. That's going to go in the back. So we get 10x plus 1 10x minus 1, and you're done. So those ones are all really simple ones to do. Let's look at some that might be a little bit more complicated. If I look at this example, I see I have something minus another number, but 3 is not a perfect square, neither is 12. So when you run into ones like this where the numbers aren't a perfect square, try factoring out and see if there's a greatest common factor that maybe if you take that number out will make it so it works. So if I look at 3 and 12, I can take a 3 out of each of those. So our greatest common factor here is a 3, and if I take that out, I'm left with x squared, and 12 divided by 3 is 4. So now that that 3 is out, if I look at x squared and 4, those are now both perfect squares. So I can factor this part to be 1 a plus, 1 a minus, but just don't forget the 3 that we took out originally. Square root of x squared is x, so that's going to go in the front. The square root of 4 is 2. So you'll run into ones like this where maybe you can't do the difference of squares shortcut initially, but if you factor out a common factor, then it will work and you can break down and finish it from there. Just make sure when you do this that you don't forget to write the common factor in the front in your answer, because then you'll get it wrong. Okay, let's look at another one. If you notice here, I have a power of 4. Kind of wrote that bad, but it's a 4. So that's a little bit different because so far we've only been looking when it's a power of 2. So this will work as long as we have these even exponents. And that's because if I think of x to the 4th, I'm just going to kind of write this on the side. X to the 4th is the same as x squared being squared again. So whenever you have a power raised to another power, remember we multiply them. So 2 times 2 is 4. So as long as this number is an even number, you'll be able to break it apart like this, where you're going to have x to some power being squared. And then it's going to be a difference of a square because whatever's on the inside is being squared. So I can think of this as being 2x squared squared, and then we have the minus 8. But if I look at 2 and 8, they still aren't perfect squares. So we want to factor out a common factor again like we did on the last example. So 2 goes into both of these. So if I take a 2 out, I'm going to have 2x squared. I'm going to keep writing it like this, squared. And then 8 divided by 2 is 4. So now I have a perfect square being squared and another perfect square. So when I write my answer, I want to make sure I keep the 2 in the front, but then I will have the plus minus part. Because this was really an x to the 4th, when I square root it, I get the x squared back. So I'm taking just the inside here, and that's going to go on the front. But then the square root of 4 is 2, and that's going to go in the back. And so then you'll have your answer here. So those ones can be a little bit tricky when you have the different powers, but as long as it's an even number, it's going to work. Maybe I'll do another one off the side really quick. Let's say I had an x to the 6th. I could write that as x cubed being squared. So then x cubed would be the number that goes on the inside. I could do x to the 8th. That would be like doing x to the 4th squared. So as long as it's divisible by 2, whatever this number is divided by 2 is going to go on the inside, and that will be what you can write at the front of your equation. So a little practice there. Let's look at another one. I say I have an x squared on this one, so I don't need to worry about exponents, but 3 and 27 are not perfect squares. So when I see that, I can't just jump right to doing my factorization. I want to think, is there a common factor that I can pull out first that will make it so I can do my little shortcut? So I know 3 goes into both of these numbers. So if we take the 3 out, 3x squared divided by 3 is x squared. 27 divided by 3 is 9. And once I take that 3 out, x squared is a perfect square, 9 is a perfect square. So we have a difference of perfect squares again. So now I can factor that inside a little bit more and do our shortcut. But don't forget to write that 3 in the front still. The first one's plus, that one's a minus. Now to get the insides, we just take the square root. So the square root of x squared is x, that goes in the front part, and the square root of 9 is 3, and that goes in the back. And then you're done. So again, it might not work initially, but as soon as you take that common factor out, then you have a difference of squares and you can use your little shortcut. Okay, on this one we have another power of 4. So remember, you can write that or think of x to the 4th as being x squared squared, so that I have something squared for our perfect square. And then 16 is also perfect square. I can think of that as being 4 squared. So when I factor it, since I have that difference of squares, I can do my little shortcut with the plus and minus. The square root of x to the 4th is x squared. That's going to go on the inside, on the front. And then the square root of 16 is 4. And I can write that out to the side as well. So the square root of x to the 4th is x squared, and the square root of 16 is 4. So those are going in the front and the back, and then you're done. Okay, and then on this one, see we have a perfect square and a perfect square, but here's a trick that you will see. I see it on the ACT a lot too, where they'll throw one like this. See how this is a plus sign instead of a subtraction? Remember, we're doing a difference of squares, not a sum of squares. Sum means to add. Difference means to subtract. So if we have perfect squares being added, we can't factor this one. At least not yet. You guys haven't learned to do it. Next year, you'll learn what to do when it's a sum. So you might run into problems like this on your homework. Keep an eye out if it's a plus. We don't know how to factor it yet, so you don't need to do it. So you're just done. There's no answer on this one. So keep an eye out for the pluses. They have to be a subtraction in order for our shortcut to work that we're looking at. So whenever it's a plus, for now, you're going to move on until next year when you learn how to do a sum of squares. But for your homework, you're just going to do 2.4 on Math Excel. And as always, if you have any questions, feel free to shoot me an email. I am here to help. Have a great day. See you guys later.